Robert Reed describes himself as a reformed engineer who is currently working for HPDD at Intel. I'll leave it at that. Take it away, Robert.
Thanks, Sims. So, Lustre on Amazon. So the goal here is looking at applications like HPC applications on the cloud, which are actually happening more and more these days, and other applications that could use a shared parallel file system. POSIX isn't dead yet, even though we still would like to kill it. But it's still there, it's still used, easy to use, applications like to use it, users like it for some reasons, and of course they don't like it for other reasons. Lustre has some advantages that might work well in the cloud. I mean, beyond being POSIX, it's very efficient, it can be very scalable, it can be efficient. So let's just see, so the goal here is really just to see how it works and doing it. So on Amazon, there's a couple storage options some people may or may not be familiar with. So Amazon, of course, AWS is running virtual machines, and you can rent them, by the hour. And there's basically two kinds of storage that you can get with a virtual machine. It's either the ephemeral storage, and ephemeral means, by the way, lasting for a very short time. So it's probably the most realistic description of a storage product in the history of storage products. So ephemeral storage is basically the local storage of an instance. It's the local disk. It's quick. It's reasonable bandwidth if it's not too busy. But when the instance goes away, that storage is gone. So that's the ephemeral part. And it's elastic block storage is essentially network block storage, network iSCSI devices or whatever. Amazon isn't too forthcoming on the details, but it's network storage. And those are limited in size to 1 terabyte each, but you can have as many on an instance as you want to have. Though they're all connected basically through a virtual gigabit interface, so there's a limit on how many it makes sense to have. And there's also, of course, S3 out there, which is this web object storage. It can be very fast and scalable because it's a very wide interface to the storage, and so you can get lots of parallelism and get good performance from that in parallel. But it's not really coherent, especially across regions. It takes a while for the copies to get updated across regions or even within a center. So it's not really usable for sharing data during a computation. It's probably good for before and after, but during computation, if you need to share data, you do need to get some kind of shared file system. Some recent enhancements in in Amazon that kind of looks well suited to storage solutions one is the EBS optimized flag, which gives you a dedicated virtual gigabit link just to EBS. And so I've been using that for the testing and sticking with the gigabit option. Some instances have that. Not all instance types have that option. And then other options is you can get provisioned IOPS, so you can buy how many IOPS you want to have for a particular EBS, anywhere from 100 to 2,000 IOPS. It gets a bit pricey. It can almost triple the cost, or more than triple the cost of the EBS volume, depending on how much you go for. But it's most likely they're doing this on SSD, so they can actually guarantee a 99% rate of what you've paid for. I haven't done much testing with that yet. And there's two new instance types, each which work well with the cluster compute instances in Amazon that have a 10 gig network, and these connect to that. And there's one option that has lots of SSD, another option that has a bunch of spindles. But in both cases, that extra storage is ephemeral again. That's local storage to that instance, so it's not persistent. It's useful if you want to build a very short-lived file system that's as best performance as you can get, but for something more persistent, you want to use EBS. And so what I've been testing with is mostly EBS. It's going to be the slowest option, kind of a baseline performance of worst case of what we see on Amazon. So deploying Lustre on Amazon. So one of the neat things about the environment in AWS is that it's very programmable. They have APIs for everything. You can manage everything through code. And it's a little frustrating at times because you've got to learn a bunch of APIs, but it's really like application development, but your data center is the application, and it's really kind of neat, actually. So in this environment, what I'm using is I've got a custom Amazon machine image that's just got Lustre pre-installed in it. Because servers need a custom kernel, it's kind of annoying to just take a standard Linux instance and install Lustre when it boots, which is kind of the standard method for using Amazon, because you have to reboot it again to get the new kernel running. So I just created a custom AMI that the kernel's already in there and some other bits. And then I'm using a tool, another Amazon tool called CloudFormation, which allows you to define a template, which is in a JSON format, which I'll say it's better than XML, but it's still kind of painful. But you define your template of all the resources that you want to have in a cluster, the compute, the network, users, Amazon resource type users, firewalls and the network, and kind of anything you want to use, you define in there. Amazon creates it for you, then gives you hooks to customize the instances and run scripts to do your own customization. And you can combine that with something like Chef or Puppet to really go to town on configuring these. I didn't go that far, but I just wrote some custom scripts to deploy Lustre, and I'll walk through that in the next slide. And the idea is to build the file system up dynamically as the nodes boot. So there's no central manager here. So the way it works is the cluster formation, you give it the template and you tell it to go, and it starts creating the resources. And as part of the template, the CloudFormation is giving each instance a personality. So it tells it you're an MGS, you're an OSS, you're an MDS, and also some storage. And so the first one that comes up and says, oh, I'm an MGS, and says, okay, I'm first. So I go and initialize myself and format the local storage as an MGS, and then I go update this little DynamoDB database, which is just an Amazon NoSQL service that they just have an offering for, so I just took advantage of it. So it just updates that, says, I'm the MGS for this file system, so, and here's my NID. And that's the one thing you pretty much need to know to format yourself. So the other targets then, starting with the MDS, says, okay, the NID is now there, I can go format myself, and then register the first MDS target to the MGS. And so now the file system record has been created on the MGS. So the MGS now knows about the file system at the Lustre level, and then MDS updates the database, and then everyone else says, okay, now the file system's started to become configured, and so all the other targets start formatting themselves. And also at this point, clients can mount the file system if they're using this system. And eventually everything's up and running, and you can see the things happen in the database, but you can also just look at it from a Lustre client and see the targets being added to the file system with the LFS OSTs command. So the benchmarking I've done is really just to kick the tires. I've done a very initial phase of benchmarking, just focusing on the standard sequential I/O and metadata ops, crates per second, really. And there's a more thorough evaluation that's in progress by more patient and diligent engineers than myself, who will do a better write-up on a more detailed analysis of various different Amazon resources and how they might be used for Lustre. Because there's also a cost-performance analysis to be done, too, for different parameters. Do you use the really fast storage, or do you just use lots of the slow ones because they're significantly cheaper? So the basic configuration I'm using for the Lustre servers are the M1 X large instance type. Those are the cheapest instance that has the full gigabit EBS optimized option, basically. They have 4 virtual CPUs, 15 gigabytes of RAM. And I'm just doing RAID 0 over the EBS volumes in all cases. So the MDS is actually 8, and then it's in another graph 16. So 8 EBS volumes for MDS, RAID 0, and then the OSSs have 4 each, again RAID 0. Amazon does say that a 1 terabyte EBS, the max size EBS, will be the best, most stable performance, but it's 10 times more than 100 gigabytes. So I think that's more of and it is slightly better in performance, but it's more of a capacity decision. So if you're doing this for a real file system, you would probably go full capacity and get full terabyte and get a little bit smoother performance. And in this case, 32 clients. And here's the results. And so the clients across the bottom, each group of bars is clients for one client on the far left, and then the bars are number of threads per client. So the first little bar on the far left is 1 thread per 1 client. We can't saturate the gigabit talking to just one OST. And it's a virtual gigabit. But as soon as you get to more than 1 thread on the client, that client's link is saturated. And then as you add more clients, it saturates until you get to, remember, there's 10 OSTs. And so at that point, you've maxed out the OST, no more performance, but it stays pretty stable. This is for sequential writes. This is a file per process writes. It's not I did a shared one as well, and it was actually a little bit lower. It didn't get above about 800, but it was actually much smoother. Sequential read Now, this is interesting, because remember I said it's virtual gigabit links. If you look at the one node option there, it's going beyond a gigabit performance, over 200 megabytes, actually, when you have lots of threads. So this is something, I kind of Googled that and said, okay, what's going on? And actually, on Amazon, this has been reported. Other people see this. People have also seen it for the writes, though I didn't. So apparently, these are actual virtual links, and there is some kind of 10 gig going on underneath, which makes sense because each instance now has 2 links. They're probably using the same 10 gig link for both the EBS optimized as well as this link. So yeah, it's a black box, though, so it's kind of mysterious to kind of poke at different things and see what happens. So in this case, as long as your clients were less than the number of OSTs, we're actually getting better than gigabit performance. And then once we saturated the OSTs again, that performance kind of came back down to what you'd expect. But, yeah, well over a gigabyte, which I thought was pretty decent for little virtual machines. So and then I did metadata testing, used MDS rate. But I was following a similar, MDS rate is what Diwang was testing for the metadata cluster, DNE earlier today. And I was also looking at how Liang tested the MDNS scalability last year for 2.3. And so I kind of followed his example for this, but so basically, the results are the same layout of the graph. These are threads, but the thread blended didn't fit. And so essentially, with one MDT, we got pegging out at about 5,000 crates a second. These are zero stripe crates, so OSSs don't matter. But now that we've got DNE, I thought, well, let's, and also Amazon, you can create new instances easily. Let's try more MDTs. So I went to 16 MDTs, and in this case, the stripes are number of MDTs, they're not threads. Every run here had 16 threads. So with one of these clients, you don't get any benefit from it, but as you increase the clients, increase the MDTs, you get really good scalability for crates, and it goes up to about 80,000 crates a second. Actually, it's really great scalability up to 16, and then at that point, you get still a good improvement, but it starts to tail off. And at that point, you're saturated MDTs. And then I did one more run, actually last night, and with 32 clients that were actually a much larger client, with 8 cores, and a bit fewer runs, but with 4 clients, they was able to saturate all 32 MDTs in this case. Well, not quite saturate, but it was able to saturate, say, up to about 8 MDTs and a little bit more. Then going on up to 32 clients, and getting 140-something, almost 150,000 crates per second with 32 MDTs, and then at 48 clients, it's fairly stable. It didn't really increase much, so we had saturated the MDTs at that point. So, early conclusions: Lustre, it runs well, as well as you could be expected on this kind of infrastructure, and Amazon's infrastructure allows for Lustre to scale well because it's flexible. You can add more nodes as you need it. You need more OSSs, you can add them. Or MDTs, you can add them now with DNE, and which is a good fit for Amazon. And then, by the way, just point about the DNE, this is a file per directory, that testing. So the current DNE only scales at the directory level. So if you have, thread per directory, not file per directory. There's more than one file per directory. But it's thread per directory in this case, because the directories, you need different directories to scale across multiple MDTs. The current version of DNE has that limitation. But what I'd like to see is Lustre having a little bit more support for a dynamic failover configuration to be able to do failover style recovery on Amazon and create a new instance when one dies and reconnect the EBS. And also, I'd love to see something like an HSM to S3 connector, so we can do dump data from Amazon, from Lustre into S3, or vice versa, pull it back out of S3 and hydrate a file system really quickly by restoring the namespace, then having HSM pull it in from S3. That would be really neat, but yeah, that's it. Any questions?
Did you have to copy all the Lustre files into Amazon, or did they help you to do that?
What do you mean Lustre files?
I mean, when you install the Lustre on Amazon, you create this. Did you copy the files through the net to this environment, or did Amazon people help you?
So I was just doing benchmarks. So I was starting. There were no data on the file system to start with. Just using IOR and MDS rates.
Okay.
Yeah. Actually, at first I thought you meant Lustre packages, and the Lustre packages is running on those instances are the same. I just downloaded them from the, I was going to say WAM Cloud, but the Intel download site for Lustre. So they're just the same binary kernel and Lustre modules that were available for Lustre 2.4 that day that I downloaded them about 2 weeks ago. So it's a standard kernel. I didn't have to build anything, except on the client side.
Would you perhaps like to invite folks to kick the tires, maybe?
Yeah, if anyone's interested to try this, we'd love to talk to you. And if you have some users that would like to experiment with Lustre on the web or on cloud, we would definitely like to talk to you or your users and get you access to what we've got going.
Compare this to others, sorry, could you compare this to any other systems to, like, relative to anything else?
Like other file systems?
Yeah.
Yeah, so we haven't done any direct comparisons. And before Red Hat bought Lustre, they had actually published a lot of information about running Lustre on Amazon. And their performance wasn't as good, but they're doing replication, so that's consuming a lot more of the network. But I haven't seen as much of that data since Red Hat bought them. They're still doing it, but they're not pushing it as hard as Lustre was, I think. Isilon also has a virtual appliance available, but I don't see any information about it, and it's not free. I don't think. Well, it's commercial. It's not open source.
All right. That's all we got time for. Thanks, Robert.
Thank you.